Hi, my name is Anika Valaru, and this is my lab report for Lab 4 in Physics 2212. The purpose of this lab is to observe a bar magnet falling through a tube of aluminum foil and model the interaction. The models and principles involved are magnetic flux, Faraday's law, Lenz's law, Biot-Savart law, Newton's second and third laws, and the force due to gravity being equal to the mass of the object times the acceleration due to gravity. Assumptions and initial conditions include nothing is interfering with the magnetometer on my phone except the bar magnet and Earth's magnetic field, and nothing is acting on the magnet except Earth and the aluminum foil, so there's no resistance either, air resistance. Materials include a ruler, my phone with the magnetometer and a camera, a bar magnet, and a roll of aluminum foil. So this is a preview of the results. The average time it took for the magnet to fall through the tube was 1.114 seconds, and the graph shows how the acceleration of the magnet slowed down and came to 0 as it fell through the tube. So the main idea as we're looking at interactions with magnets, system is the bar magnet and the surroundings are the Earth, the tube, and everything else. So setup, I first found which side of the bar magnet was the North Pole using the magnetometer on my phone. So as the end of the magnet got closer to the magnetometer, if the z-axis value increased, that end would be the North Pole. If the z-axis values decreased, that end would be the South Pole. And then I actually used tape and a marker to mark which side was the North Pole. And then I set up my phone on a chair to record. And here on the right you can see one of the recordings I did. I dropped the magnet through the tube 5 times, and then using the video I found how long it took for the magnet to fall through the tube each time, as well as the average time it took. So you can see my calculations on the right in the bottom here, and the average time was 1.114 seconds. So then I went to GlowScript to model the interactions. I started with the starter code. I added in all the relevant values. I wrote in the equations to calculate the magnetic field, magnetic flux, magnetic force, and net force. I also, at the end, included the velocity and position update. So here is what the model looked like. The acceleration of the magnet decreases and the velocity becomes constant. Red is the counterclockwise direction and blue is the clockwise direction using Lenz's law. If the magnet were to be flipped, the way it falls would be the same, but the directions of the currents would flip. The computational time was longer, so the time found through the model was actually longer than the time found through the actual real-life experiment, though that could have been due to errors, specifically in the code. The plot shape tells us that the forces pretty much cancel out while the magnet is in the tube, because you can see if the acceleration is 0, that means the net force is 0, and yeah, so the magnet doesn't necessarily slow down until the end, but you can see that it gets faster up to a point and then its velocity stays constant. So similarities, differences, and error. For similarities, the magnet stops accelerating while in the tube in real life and in the model. The difference is the time taken did not match. So the experimental value was a lot bigger. I think it was about 13. And so this is most likely due to some error, so my measurements may have been inaccurate. My mu value may be incorrect. There may be some error I missed in the coding, and I noticed that while I was dropping the magnet may have also made contact with the top of the tube as it was falling through, so that may have done something with my measurements. Okay, what if? What if the resistivity of the conductor were reduced as close as possible to 0? How will the dynamics of the falling magnet change? So the induced current would increase, which would make the opposing magnetic field stronger, and then this would mean that there is greater resistance and the magnet would slow down even more. And I found this using Ohm's law. And then What if holes or slots were cut into the tube? How would this affect the ring currents in your model? So there would be fewer of the ring currents because there's like less space in the tube. So this would make the opposing magnetic force smaller. This also means that there would be less resistance and the magnet would fall faster. Thank you for listening to my lab report.